And this is my lab report for Lab 1 constant velocity. So the goals of this lab were to use Newton's second law to understand how net force, velocity, and momentum are related. We used the equation F net equals the change in momentum over the change in time. This was used to predict the motion of an object moving with constant velocity. We used the position update formula and the velocity update formula, and we also analyzed the video in Tracker and created a computer model in GlowScript. So the lab setup. We used an expo marker, which had a diameter of 1.8 centimeters, and a lab table. This is a video of our motion. We put this video into Tracker, and we oriented the axes in the negative x direction. We used a calibration stick that was set to the diameter of the marker with the initial position of 0, 0, 0 and the initial velocity of negative 0.236. If the axes were oriented differently, then the magnitude of r would just be negative r. So ours was, an example would be the purple line, but then if we flip the axes, it would be the red line. This was our GlowScript program initialization. So we had the marker mass, which was 0.03, the initial position, which was 0, 0, 0, the initial velocity, which was negative 0.236 in the x direction, then 0 and 0 for y and z. And then the time range, which was from 0, and the delta t was 0.00033. And then the net force was 0 because it was a constant velocity. Here's the GlowScript program. All right, and this is our formulas and what was outputted. All right, so creating the comparison graph. We use time position data from Tracker as well as the time position data from GlowScript. We got the Tracker data from placing the location of the ball across each time frame, and then we got the GlowScript data from the computer model. So we created a line graph with the data from GlowScript and Tracker, and as you can see, Tracker had some irregularities just because it was the experimental data, and then GlowScript had a straight line. They're pretty similar, but some possible causes for irregularities are outside forces like a slant of the table, unstable filming, and then a blurred center of mass on the Tracker application to where we couldn't quite get the exact center point. Some improvements we could do would be use a different surface to roll the marker to minimize friction and make sure it was a completely horizontal surface, as well as we could have used better camera quality for better accuracy, and then include friction and drag forces. This means that the net force is 0, or the net force of 0 is the sum of other forces. So that includes gravity, normal force, drag, friction. So the net force of 0 is for our model, and the other components of the net force are not included because we cannot determine them. So in conclusion, we used Newton's second law, which is F net equals the change in momentum over the change in time, using the velocity update formula and position update formula to show the constant velocity. And yeah, thank you.